Good morning. Myself, Prabhakaran Che, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is Multirate DSP from Unit 5, that is DSP application. From the subject name is Digital Signal Processing. Yeah, let me discuss. Uh, Before that, what is meant by Multirate DSP? Yeah, the processing of a discrete time signal at different sampling rates in different part of system is called multirate DSP. Okay, multirate DSP means the processing of a discrete time signal at different sampling rate in different part of a system. Okay, okay. Next one is what is meant by a multi-rate DSP system? Yeah, multi-rate DSP system. The discrete time systems that employ sampling rate conversion while processing the discrete time signals, which is called multi-rate DSP system. And next one is sampling rate conversion, which means the process of converting a signal from uh, one sampling rate to another sampling rate. This is called sampling rate conversion. There are two general methods for sampling rate conversion. In the first method, the discrete signal converted to analog signal using D2A converter, which means digital to analog converter, and the analog signals is resampled at the desired rate using a to D converter. There are two ways of sampling rate conversion in digital domain. They are, first one is decimation, which is downsampling, and the second one is interpolation, which is upsampling. And what is meant by decimation and interpolation? Let me see. Uh, Downsampling or decimation is the process of reducing the sampling rate by an integer factor D, capital D. And upsampling or interpolation is the process of increasing the sampling rate by an integer factor I. And let me discuss the what are the advantages of multi-rate signal processing. Yeah, the first one is reduction in number of computation levels, to reduction in number of computation. When we are using multi-rate signal processing, this is the advantage, first advantage. And another one is reduction in memory requirement for filter coefficients or intermediate result. um, this is the second advantage. And third one was reduction in the order of the system, and finite word length effect are reduced. And a narrow band FIR, IIR, finite impulse response filter, infinite impulse response filter for various applications. Oversampling A to D, D to A converters for high quality digital audio systems and data loggers. In digital audio systems, the sampling rate of broadcasted signal from all these devices, sampling rate converters are needed in a digital audio systems. These all are the advantages of multi-rate signal processing. And downsampling. Downsampling or decimation, already we have discussed. Downsampling is the process of reducing the sampling rate by an integer capital D. D is nothing but the downsampling factor. And here you can see the diagram. X of n is nothing but the input of the system, and down arrow with capital T, this is the downsampling factor, and y of n is nothing but the output of the downsampled signal. Okay, okay. Yeah, let me do one small classroom activity. Here you can see two tables. First table, it consists of four column. The value of first column and the value of second column equal to value of fourth column value. Likewise, value of first column is 10 and value of second column is 9. What is the value of fourth column? You have to find. And second activity is 3 chicken value equal to 60 and 1 chicken plus 2 plate of egg equal to 26 and 1 plate of egg plus 2 bunch of banana equal to 15. Now let me now you have to find one chicken plus one plate of egg and one bunch of banana. What is the value of uh, this one chicken plus one plate of egg and one bunch of banana? And answer me through the comment. Okay. Okay, let me see one small example. Consider the discrete time signal x of n equal to 1 to 12. Okay, you have to find a downsampled version of the signals for sampling rate reduction factor d equal to 2, d equal to 3, d equal to 4. Okay. Okay, uh, let me let me solution. Let me find the solution. Mm, what is the input signal? Input signal is nothing but the x of n equal to 1 to 12. This upper arrow represent the origin of the signal. Okay, okay. When n equal to 0, the value of x of n equal to 1. When n equal to 1, the value of x of n equal to 2. When n equal to 3, the value of x of 2 equal to 3. When n equal to 4, the value of x of 4 equal to 5. When n equal to 5, the value of x of 5 equal to 6. Likewise, when n equal to 11, the value of x of 12 equal to 12. Okay. Okay. Uh, Let me find the sampling rate reduction for d equal to 2. This is the capital D is nothing but the uh, reduction factor, sampling rate reduction factor. Now x of capital Dn equal to because x of 2n because d equal to 2, discrete time signal decimated by reduction factor 2. uh, Let me consider x of 2n equal to x suffix d2 of n. When n equal to 0, x d2n equal to x of, because 2 into n, 2 into n, yeah, what is the value of n? N equal to 0, x of 0 equal to 1. Okay, when n equal to 1, x of d2n equal to a capital X of 2 into 2 is the downsampling factor, 2 into, because d equal to 2 into 1 is nothing but the small n value, because so capital X equal to 2 equal to 3, value is 3. X of 2 value, what is the value of x of 2? X of 2 is the 3. And likewise x of 4 equal to 5. X of for n equal to 3, x of 6 equal to 7, for n equal to 4, x of 8 equal to 9, for n equal to 5, x of 10 equal to 11. The answer is x of 2n for d equal to 2. X of 2n equal to 1, 3, 5, 7, 9, 11. This upper arrow represent the origin of the signal. Okay, x of 0 equal to 1, downsampled version of the signal. This is the output of the signal for downsampling factor d equal to 2. Likewise, for d equal to 3, value is 1, 4, 7, 10. For d equal to 4, value is 1, 5, 9. Okay. Okay, this is the another and final one is anti-aliasing filter. Anti-aliasing filter, here you can see the diagram. Anti-aliasing filter is placed before the downsampling. Okay. Okay, when the input signal to the decimator is not band limited, then the spectrum of decimated signal has aliasing. Aliasing is nothing but the noise of the signal. In order to avoid aliasing, the input signal should be band limited to pi by capital D for decimation by a factor D. Hence, the input signal is passed through a low pass filter with bandwidth of pi by d before decimation. Since this low pass filter is designed to avoid aliasing in the output spectrum of decimator, it is called anti-aliasing filter. And this is the assessment of this video lecture. uh, First question is define multirate DSP, and second question is the discrete time systems that employ sampling rate conversion while processing the discrete time signals are called. What is meant by sampling rate conversion? List the two ways of sampling rate conversion in the digital domain. What is mean by downsampling and upsampling, and what are the advantages of multirate processing. Summarize the application of multirate DSP, define anti-aliasing filter. These all are the assessment question for this lecture video. And if you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.